Now, think about how often you use the internet to to send an email, or maybe to look up something important, or maybe to buy something using your credit card number. And how often do you maybe worry that someone could hack in and see your information? Well, now scientists are working on building a quantum internet that could help keep our information safe by harnessing the properties of quantum mechanics. Quantum mechanics is the science that describes how the tiniest building blocks in our universe work, things like atoms and subatomic particles and photons, which are particles of light. So how do we use these atoms and particles to build a quantum internet? Well, let's look at a simplified description of how our regular internet works, and then how a quantum internet would work. Now, to send information over our regular internet, like an email, that information is encoded in bits, series of zeros and ones. And those bits are sent as pulses of light through fiber optic cables that can relay the information to computers all over the world. Now, to keep that signal strong as it travels, the information can pass through repeaters, which can boost the signal and make sure that it gets where it's going. In a quantum internet, information is sent between machines called quantum computers. And quantum computers don't use regular bits. They use something called quantum bits, or qubits. And in the case of a quantum internet, these qubits are made out of photons, individual particles of light. And these photon qubits are linked together using a property of quantum mechanics called entanglement. Now, entangled qubits have a really powerful connection between them, but that connection is always broken if someone tries to take a measurement of these qubits, which is exactly what someone would need to do if they were going to try to sneak into the quantum internet and steal your credit card information. So because of entanglement, we would always know if someone was trying to break in, because they would break the entanglement between qubits. The key to your information would be protected by the laws of quantum mechanics, the laws of nature. So why don't we have a quantum internet yet? Well, encoding information into individual photons of light and sending it through cables is really hard to do, in large part because qubits are extremely fragile, and it's really, really easy for them to lose their information along the way. So as of right now, information traveling from a quantum computer on one side of the world couldn't come close to reaching a quantum computer on the other side of the world, or even in the next state. So to solve this problem, scientists have been trying to build something called a quantum repeater. Now, these devices could be placed along the communication lines, and they would be used to trap and store these photon qubits and then allow them to be processed in a way that can transport the information to its final destination. And now scientists have been working for years to try and build these quantum repeaters. It's considered the missing link needed to finally complete the quantum internet. And now, in a paper published just recently in the journal Nature, scientists from MIT and Harvard worked together to build a quantum repeater out of diamonds. But not the kind of diamonds that we usually think of. These quantum repeaters are built out of teeny tiny atomic scale structures that are built inside the diamonds. They're called silicon vacancy centers. And to see these, we need to zoom in way down, all the way into the individual atoms that make up the diamond. Now, diamonds are made of carbon atoms. But to make these silicon vacancy centers in the diamond, scientists remove 2 carbon atoms and they replace them with 1 silicon atom. And they do this in a way that leaves 2 holes or vacancies on either side of that silicon atom. Now, they create these silicon vacancy centers and they put them inside teeny tiny cavities that they build inside these diamonds. And because of the quantum properties of these silicon vacancy centers, they're able to do all of the things that a quantum repeater needs to do. They can trap and store these photon qubits, and then allow them to be processed so that they can be transmitted to their endpoint. Now, there's still a lot of work that needs to be done before we have a real worldwide quantum internet, but these new diamond quantum repeaters are a big step towards achieving that unhackable communication.